So hello my dear student friends, we'll try to understand how a diode is different from BJT today in very layman terms. So to start with, we'll have to understand what a diode is and then what a BJT is in very simple terms, and then let us try to understand how both of them are different with respect to each other. So to start with, what is a diode? Well, the definition of the diode says that it's a two-terminal device. Okay, so it's a two-terminal semiconductor device that allows the current to flow primarily in one direction, whereas the current in the opposite direction is blocked. So that's a very important point with respect to a two-terminal diode. So when we look at the structure of a diode, well, it's a PN junction. Okay, so what do we mean by a PN junction? Structurally, one layer of P type and another layer of N type are joined together. Then the joining place is called as a junction. Okay, we also call it as a depletion region. Now, so this particular diode is formed by joining a p-type semiconductor. Now when we say p-type, well, it is rich with respect to holes, and also a n-type semiconductor which is rich in electrons. So the symbol of a diode, since a diode is a two-terminal device, the two terminals of a diode are anode and cathode. We usually say that anode is positive and cathode is negative. So with respect to the device as such, now if you want to identify the terminals of a diode, the real-time diode, well, we can observe that there is a small silver color patch on one side of the device. This indicates the cathode terminal, whereas the other side will be the anode. Now, most importantly, which all functions or what all functions can a diode do? A diode can conduct or block the current. So we had already discussed that the diode allows the current to flow in one direction, whereas in the opposite direction it blocks the current to flow. So this particular thing is also called as rectification. Okay, so what do we mean by rectification? Well, in actual terms, it is AC to DC conversion. A diode can also be used as a switch. When we say switch, it means from on to off and vice versa. A diode can also be used to clip a particular signal. Okay, so what do we mean by clipper? Clippers are the diode based circuits which remove a certain portion of the signal. Okay, so it could either be the positive portion or the negative portion of a signal. Diodes can also be used as clampers. Well, the word clamp means it's a DC shift. So a diode can be used in clamper circuits also. So these are some of the most important functionalities with respect to a diode. Now there is a question, and that one is, can a diode amplify? The answer is no. A diode cannot provide power gain, which means it just cannot amplify signals. So in layman terms, what we can say is that a diode cannot amplify signals. It cannot function as an amplifier under normal circumstances. So well, this can be considered as a major drawback with respect to a normal diode. Alright, so I think we have understood some basic things with respect to a diode. Now moving forward, let us try to understand some things with respect to a BJT. Well, BJT stands for Bipolar Junction Transistor. Now the word bipolar means the current conductivity in a BJT is due to holes as well as electrons. Okay, so this is a very important thing which we'll have to understand with respect to a BJT. So the current that flows in a BJT is due to holes as well as electrons. Hence it is called as a bipolar junction transistor. Now coming to the terminals with respect to a BJT. Well, a BJT is a 3-terminal semiconductor device. Now just to go back to the diode, we had seen that a diode is a 2-terminal device, whereas a BJT is a 3-terminal device. Now in some of the textbooks there will be a definition written which says a BJT is a structure wherein 2 diodes are connected back to back. Well, that is very true. However, we will have to apply certain conditions to it. Then, so we had seen that a diode cannot amplify a signal. Then what about a BJT? Well, a BJT can amplify signal. Okay, so which means a BJT has got the capability to amplify current, to amplify voltage, and very well the power gain. Plus, a BJT can also be used as a switching device. Okay, so which means it is the amplification that completely distinguishes it from a normal diode. Now when it comes to the structure, a BJT has 3 semiconductor regions. The first one is called as emitter, which supplies charge carriers. The second region is called as base. Usually the base is very thin. However, this actually is called as a control region. And finally the collector. So as the name indicates, this region collects the charge carriers. Okay, so again emitter, base, and then the collector. Moving forward, well, this is a very simple cartoonic illustration of how a BJT looks like. So as we had seen, the 3 layers are the collector, the base, and then the emitter. Now with respect to a BJT, there are 2 types or 2 flavors. The first one is called as NPN, which means a P region base is sandwiched with respect to 2 N regions. Similarly, the second flavor or the type is called as PNP. In this case, the base is of N type and emitter and collectors are of P type. So normally either N, PN or PNP type of BJTs are being used. Now with respect to the circuit symbol, how does a BJT look like? Well, this is how a BJT is symbolized. So we can very clearly see the current components with respect to a BJT. Now if we apply KCL, okay, Kirchhoff's current law, which always holds good and which says the current entering the node must be equal to the current leaving the nodes. Now if we consider this to be a node, well, we can very clearly observe that IB is the base current which enters, and similarly IC is the collector current which also enters the node, whereas IE is the emitter current which leaves the node. Now if we apply KCL, then a very simple equation gets framed, which is emitter current is equal to the summation of collector current plus the base current. Now one thing which we will have to understand is usually the base current's magnitude is very small. Emitter current and the collector currents are usually large. When it comes to magnitude, base current's magnitude is usually in microamperes whereas emitter current and the collector currents magnitude is in milliamperes. Now we also say that BJT is a current controlled device. Current controlled device. And this is the terminology which actually differentiates a BJT from a JFET. Okay. So what does it mean? Well, a small base current controls a much larger collector to emitter current. Well, this is exactly the base fundamental concept of amplification. A small base current, when it reaches the output side, it gets converted to a very large collector to emitter current due to the amplifying action of a transistor. Okay, well, so I think we have understood a little bit with respect to a BJT also. Now moving forward again, asking the same question, how is a diode related to a BJT? Are they the same? No, definitely they are not the same. But structurally, we can say that a BJT consists of two diodes which are connected back to back. However, we will have to understand that one BJT is definitely not equal to two diodes. Okay, so once we understand it, then we can very clearly understand diode and then differentiate it from a BJT. So the working of a BJT is completely different from a diode. We normally use diodes for rectification purpose, switching purpose, clipping purpose, clamping purpose, and many more. However, one thing that is missing in diode is amplification. Now it is the BJT that has got the capability of amplifying a particular input signal. So it could either be current amplification, voltage, or a combination called power amplification. So I hope now students are clear with respect to a diode and a BJT, and they can very well relate both of them qualitatively. Yes, thank you very much, students.